Hello guys, welcome. Today we are here to discuss about a question called squares of a sorted array. Question number 977 from Lead Code. Let's jump into the question. So given an integer array nums sorted in non-decreasing order. So they are giving us an array nums sorted in non-decreasing order. Keep this point in mind. Non-decreasing is nothing but increasing, but only difference between these two is increasing order does not have any duplicates, but non-decreasing order have duplicates. Such thing, something example like this, 2 to 3. If you observe, this is not increasing order. Okay, because these two are same values. So whenever you have duplicate values in an array and the array is sorted in ascending order, then that array is called as non-decreasing order. Return an array of squares of each number sorted in non-decreasing order. So they're giving us an array and they were asking us to return an array. Okay, giving us an array and they are asking us to return an array where this array contains squares of each number from the main array. Squares of this numbers. Okay, for example, 2, 3, 4. Squares of this number should be present in the answer array. That's all, guys. For example, 2 square 4, 3 square 9, and 4 square 16. That's all. This should be your answer that we need to return. You might be thinking here, what is like sorted in non-descending order? Already this is in non-descending order. Why I will get it in? When I simply square this value 2 into 2, 4, I can directly place here. You might be thinking, this is already sorted. Obviously, answer will directly sorted. There is no point of why they're exclusively, explicitly asking us to sort here. You might be thinking in that particular way, guys. But here comes your main thing, that array contains negative values. Array contains negative values, minus 10 power 4 to 10 power 4, which means array contains negative values. If you observe here, we have negative values. Now you guys say me. Now let's take an array. Minus 4 square, 16. Minus 1 square, 1. 0 square, 0. 3 square, 9. 100 square, sorry, 10 square, 100. Now, this is the answer. If you go element by element, if you go element by element in your nums array, we got this array. Okay. Is it sorted? No, this is not sorted. So we need to sort this. You can use any algorithm. Okay, you can use any algorithm or anything. Now you will sort. So after sorting, you will get this answer. So what is the time complexity here, guys? N plus n log n. This part is for sorting. Okay. And this part is for squaring the numbers. Okay. So this is the time complexity if you follow that basic way. Go to this minus 4, do square and store it in 16. Go to this minus 1, square and store. Go to 0, square and store. If you do this first step, this will take n and sorting takes n log n. So total time complexity is n plus n log n. So it will be this one, guys. But this is how the traditional way is. But is it possible to do without sorting? Is it possible? Yes, guys. Think about that one. If you observe, even in the question, they are giving us to find a big of n solution, which means they don't want us to explicitly sort again. They don't want us to sort again explicitly because they have already sorted the elements, right? It is already in non-decreasing order. Why you will sort again? Why you will sort again, guys? Huh. Think about that, guys. In the meantime, think about that one. In the meantime, I'll write answers for the above one, for above array. Now, if we convert this array into squares array, this will be something like this: 16, right? 1, 0, 9, 100. This is how the array will look like after squaring. Now, what we are thinking is we will do a sort on this. We will do a sort on this. Instead of sorting, if you observe here, the elements are big to small, big to small. Like these are the bigger elements on the right side and left side. You can ask me why we have bigger elements on the left side, because when you square negative values, they will become a positive value. Okay, which means minus 4 and 10. Okay, minus 4 and 10. 4, this you can call it as 4 only. So when you sort them, okay, when you sort, like here we are sorting it, very simple, straightforward ways. Instead of sorting, what we can do is, if you observe here, the elements are from big to small, towards left side, towards right side. So what we can do here is, instead of sorting, what we can do here is, so instead of sorting, what we can do here is, as we know the numbers are decreasing inward direction, okay, when we are doing a square, okay, when we are doing our square only, what we will do is, we will create an answer array, but we will not directly store this minus 4 value 16 here. Instead, what I will do is, I will create an empty array of same size. I will place a pointer at the end, and now I will compare minus 4 with 10. I will take the absolute values. I will take the absolute values. Absolute value is nothing but negative value will also be converted to positive value, actual value of that integer. So now 4 and 10, which is greater one? Which is greater one? Obviously 10. So what is 10 square? 100. So last element will be 100. Last element will be 100. After that, I'll go to the next place. As 10 is completed, I'll go to 3. Now 3 and minus 4. What should be the value, guys? Minus 4 square is 16. Minus 4 square is 16. And 3 square is 9. Which one should go there? Obviously 16. So place 16 here. Now move to minus 1. So in this way, we solve this question, guys. We place the pointers at extreme ends. What is the purpose of placing is, the main purpose of placing the pointers is, we know this array is sorted. This array is sorted and it contains negative values. You might be thinking, when you have negative values, always the bigger values on the right side. Why we are placing the pointer on the initially? Because we are finding squares. When you are finding squares of a numbers, negative value will turn into positive. Negative value turns into positive. That was the main idea behind this, guys. I hope you got this one. Now let's start coding this. Very simple one. Okay. Now let's take int I equal to 0, j equal to nums dot length minus 1, and we need to create an array, int answer array equal to new int of nums dot length. Okay. After creating this one, we need to have one more pointer, int p, to track your answer array. P equals to nums dot length minus 1. Okay. Now what we need to do? Very simple. For, okay, instead of writing it here, what we can do here is p equal to nums dot length minus 1, p greater than or equal to 0, p minus minus. We'll start from last. If, okay, if your absolute value, math dot absolute value of nums of I is greater than math dot absolute value of nums of j. If your first value is greater than last value, then obviously we are doing math dot absolute, guys. Why we are doing this math dot abs is to get the actual value. Minus 4 is nothing but 4. So that's what we are getting. So we are getting math dot absolute value of nums of I. If it is greater than j, then obviously math dot nums of I should be placed at answer array. Answer of p equals to nums of I into nums of I. I'm simply doing square, guys. So 2 square is 2 into 2. After that, I plus plus. Else answer of p equals to nums of j into nums of j minus minus. That's all. We will simply return answer. Now, if you observe, time complexity is simply n. We are not sorting. Instead, we figured out a point that the elements are in sorted order only. That's all, guys. This is how we solve this particular question. I hope the question and approach are clear to you people. Let's meet in the next video. Until then, see you guys.